Linear Discriminate Analysis LDA is a dimensionality reduction and classification technique used to find linear combinations of features that best separate classes in a dataset. Unlike Principal Component Analysis PCA, which focuses on maximizing the variance in the data, LDA aims to maximize the separation between classes. Here's an overview of the steps involved in linear discriminate analysis. Step 1. Data preparation. Gather a labeled dataset containing samples from different classes. Each sample should have a set of features and a corresponding class label. Step 2. Compute class statistics. For each class, calculate the class mean vector and the scatter matrix. The scatter matrix represents the spread or variation within each class. Step 3. Compute between-class and within-class scatter matrices. Calculate the between-class scatter matrix by summing the outer product of the difference between the class mean vectors and the overall mean vector, weighted by the number of samples in each class. Compute the within-class scatter matrix by summing the scatter matrices of individual classes. Step 4. Solve the eigenvalue problem. Perform an eigendecomposition on the inverse of the within-class scatter matrix multiplied by the between-class scatter matrix. This step yields eigenvectors and eigenvalues. The eigenvectors represent the linear discriminants, and the eigenvalues indicate the amount of discriminate information captured by each linear discriminate. Step 5. Select discriminate components. Sort the eigenvalues in descending order and select the top k eigenvectors, discriminate components, that correspond to the largest eigenvalues. Typically, you aim to retain components that capture a significant amount of discriminate information and can effectively separate the classes. Step 6. Project data onto discriminate components. Project the dataset onto the selected discriminate components to obtain the transformed dataset. This is done by multiplying the original data matrix by the matrix of selected eigenvectors. Step 7. Classification or analysis. The transformed dataset can be used for classification by applying a classifier algorithm, example, logistic regression, k-nearest neighbors, on the reduced feature space. LDA can also be used for exploratory analysis to visualize the data or identify important features that contribute to class separation. Linear discriminate analysis is particularly useful when dealing with classification problems and datasets with multiple classes. It seeks to find a lower-dimensional subspace that maximizes the separation between classes, enabling efficient classification and visualization of the data. It's worth noting that LDA assumes that the classes have a multivariate normal distribution and equal covariance matrices. If these assumptions are not met, alternative techniques such as quadratic discriminate analysis, QDA, or nonlinear dimensionality reduction methods may be more appropriate.